Infinite. Oh, or it's also zero. I'm listening a lot. Like realistically.
Sorry for the delay, folks. Good morning. Good morning, folks. We're going to continue today our lesson on law of sines, and I hope you memorized the law of sines formula. Yes. Okay. Did you? How many of you finished the homework in class last time? Just out of curiosity. Or that came one away from it, at least away from it.
Oh, that one. That one.
That one. Okay, make sure that you finish that one if you didn't already. We're going to continue law of sines today, but I want to examine what we've done so far. Remember, law of sines so far has been applied to two different kinds of triangles. What were the types of triangles it's been applied to? Could you check in with your neighbors, see if you remember what kind of triangles that they've been applied to?
AAS and AXA.
HL is more like SOHCAHTOA. We don't need it. You could use it, but I don't recommend using HL. Okay, so the two types that we've been focusing on are so far ASA and AAS, right? Because these are two ways to prove that two triangles are congruent. And like if I'm talking about ASA, that means we have a triangle here, and I've locked in an angle and another angle. And if I have that S in the middle, does it make sense that just you can't make another triangle? There's only one triangle that exists if you have these two angles on this side. Like if I try to erase a little, like the top of it, or I can't make another triangle. There's only one triangle that is formed if you have AS and A. Same thing with AAS. If you're given, and this is not related, but if you have this one, this, and this, it's kind of locked in place because of no choice theorem. We could bring that to the ASA, so we only have a single triangle. Today we're going to talk about another option. So far, if you have two angles and a single side, then you do have a single triangle. If you have, I think if you have SAS, be something like this, there's only a single triangle that would result from this situation, isn't there? That's why SAS results in congruent triangles. But today we're going to talk about SSA, which is not a way to prove that triangles are congruent. Do you know why? Would you take a minute to check in with your neighbors, see if they have any idea why SSA is not a way to prove that triangles are congruent?
That between the two,
Okay, so for SSA, do you know why it's not usable? Spell it backwards, of course, a little bit inappropriate for class. Yes, Maya?
Because you have like the two sides, you don't know what the angle is between those two sides. So it could be any angle, I guess, between 0 and whatever that known angle is.
Nice. Right. Yeah, if the angle's in between, it's kind of fixed, but if the angle is on one of the corners, one of the other sides, it's not quite fixed. And I'm going to talk about that today with a manipulative I brought in that we'll call the ASS board for obvious reasons. And I need to switch, I need to take video of this for people at home. So I'm going to take a moment to adjust my technology and do my work over here. So one minute, please. While I figure out what's going on here. So we need to share. Camera. Work a little bit. Okay. This is a view. I think they're gonna be able to see it home. But you don't need to see that. I'm gonna mute that. Okay, so we have this. Oh, forgot to take this off. Yeah. One moment, please. Okay, what we have is. Oh, thanks, Nick. That's really cool. Appreciate that. We have this angle here. This angle here in the corner that is fixed. We have this side that is fixed. This side here is just for reference. If we had SAS, then there would just be a single triangle here. And we go make a single triangle with that. But I'm going to talk about this A, this S, and see this S is a dashed because it's going to be movable. So I have some various lengths of sides here. I'm going to take this side right here. Do you see the triangle I can make with this? Fix it right there. Here we have A, S, and S, S, A. Yes?
Yeah.
Okay, would you please discuss the next part of the story, why SSA is not a way to prove that, or not a way to prove that two triangles or one triangle? Where am I going with this? And I'll talk about it in just a second. So, what's gonna happen? Yeah, I'm gonna take this, and in the case of SSA, the side that's opposite from the angle, we call it the swing side. You see why that happens? Take a look at this triangle. We can swing this side over here to make a completely different triangle. Right, this triangle here has the exact same information, has the SSA, same as the other one, but it's two different triangles. So it's just something you have to be aware of whenever you're given information that is S, S, and A. You do have to solve not just for one triangle, but potentially two triangles. Or do you? There are other options, because this side length may be other lengths. For instance, what if this opposite side, the swing side, is this long? You see what's going to happen? This is called not a triangle, right? It doesn't reach to the other side. This angle is too big to actually form a triangle, or this side is too short to actually reach to the other side if that angle is that long. It just doesn't make a triangle. So SSA could not, it could be two triangles, or it could be no triangles, right? So be careful. But also there's more. It could be this. This could be the swing side. This is longer than the short one and shorter than the longer one. It's the middle one so far. You see what's gonna happen? Yeah, it's gonna make exactly this right triangle here, which means it could only form one triangle. There's no swinging if it's exactly long enough to make a right triangle. So far we have a situation where we can make two triangles, can make one triangle, can make zero triangles, but wait, there's more. Take a look at this guy. pretty long. In fact, it's a little bit, it's longer than this. Would you please discuss what's about to happen? One triangle, but it makes it triangle, but it's only one, and it perfectly. If you try to swing it over, because there's a swing side. The other side, it just doesn't fit inside, it's too long. You could try to say, well, I can make it happen, I can make it happen. But you see the triangle is formed here? With a given side and this side, it doesn't include the angle that's there, it's like the supplementary angle too. Which is, it's different from our original SSA information, it just doesn't result in another triangle, so there's just one triangle. If that swing side is too long. I need to take this back in time just a little bit. Remember this guy? Remember this guy? And this is the same length. So do this. Now you may see three triangles right now. I only want you to see two. You see the two there? I want you to see the SSA triangles. So this one right here. And this one right here, they have the same SSA, SSA. Please discuss with your neighbor the relationship between this angle right here and this angle right here, right? Those opposites to side S. So it seemed like your class said almost in unison. They're supplementary. I need to know, how do you know that? Yes, Karen.
So we know that those two sides, that you just put in are the same length,
Okay,
which means the two angles below them are next to it.
okay,
And the big angle to the left is supplementary to the small angle.
these two right here.
Yeah, so
Okay.
that means because of the commutative property. The far one is also supplementary.
Are we good with that? I'm not sure it's commutative. I think it might, it's not transitive, it's because of substitution. Right, these are equal, this plus this. is equal to 1. Since these are the same, we substitute this over here. Do I care?
No.
It's not focused on the property, so arithmetic, it's not, I think it's always bringing up that one. What are these angles called when they form a line like this, do you remember? There's the supplementary, they're also a, maybe didn't look at, but special pair. A linear pair, does that sound familiar? A linear pair? Then you know if two angles form a linear pair, then they are supplementary, and you know they're linear pair because they form a straight angle. Oh, all that good if-then stuff from geometry. I remember he's rushing back, feeling you with warm. And goodness. And well, speaking of telling you with warmth and goodness, we have some math. That gets it back to the packet. Yeah, turn off my video here, switch back to the packet. And I can turn off the video, but it needs to see you back. Is it working? Here. Find both triangles that satisfy this condition. Now, let's make a summary as we have before. Actually, would you please draw the triangles? It should be two. I recommend drawing the angle in the lower left. And visualize the side, hopefully the board that I was showing right here, lower left. But you can do whatever you like. Never make sure they're able to draw the two triangles. Once you have both of them, please solve both triangles. As exact as you possibly can. Ultimately, 3 decimal places for side lengths, 1 decimal place for angle. I'm sure you've checked on your neighbor, make sure they have the right two triangles. And otherwise, it's very difficult to see.
Yeah, that's what. Oh.
Let's take the example of that.
This one should be.
Yeah, we'll just be.
Yeah, mine's 12. I was 12 on the side.
Oh.
Now I'm calculating that one thing. I don't think it's. Oh, I didn't know. How do you? How do you? Oh.
Oh, did you?
And then I put.
Yeah.
No, it's like, I come around and I'm not around.
So your neighbors supported adequately? Make sure your answers are matching.
Wait. And the word I'm like, I'm calling, don't give me a smile, it's too late. I'm thinking it's this, the 2 different. Big V is 64.73. But it should be the 100. No, because C is longer than D. But can you don't know. I know what this one. Oh, you're right. Okay, I talked about. Oh, that would be this listing.
Yeah. I didn't see it.
Yeah, but we're small. I'm finding. Oh, yeah, that makes sense. Wait, no, but I also. What about? This is the 30. Yeah.
Okay.
Yes, this is 34 when there's a trying. Also define what that. Oh, it's like.
They have to know that.
Yes.
How did you find it for the?
Oh.
You've already over these?
How was it? Oh, you know, this side, you know, this side, 12 sides.
I think the way we just. Not around the on this side. That would be. I did, but it's like.
I think it's some of the one side or something. But I don't think it's right.
Yeah.
They don't want to say that. I have to do it.
Yeah, it's like.
Yeah, there's different angles.
Then,
Well.
Like, wider one,
Oh, are they just this? This is like you need to see it. This is English. I don't know. It depends on how I got it. This was but I just be no because I think this one you just know it's like the other one. These are longer. There's no anywhere else. And then you multiply by 12, do that everywhere else beside it. Yeah, this is another sign of 2025. You know, I'm just
yeah.
draw one diagonal, it's just.
Not working out here. Oh, that, it's diagonal, it worked.
Not that.
That's the other one?
On your drawing, why is the
No.
12
Did I do it wrong?
not opposite
to the.
Oh, I put A in the wrong place. Thank you. Thank you. Good catch. So this is B, right?
Yeah.
Thank you.
Right then.
Yeah, they should have the same, right? But it's not look like it.
For this one, you know, right? One side.
Okay. Let's talk about these. If you want, as some people just kind of put the other triangle in here. Like this, and then have both of them in the same diagram. Up to you. Before I call on someone. Now, let's say we didn't have a picture. Is this enough to say, to know that we have SSA situation? Yeah. We have two sides of an angle. Is it possible this is SAS?
You have to zero it all down, that's not exactly.
But this angle, if this were here, then we'll have SAS, right? So the way it is, it's definitely SSA. And which is the swing side? Which is always going to be the swing side?
Side opposite the angle.
Well, opposite from the angle. So if this is the angle we have, this is our swing side. And I recommend, at least in the beginning, always put the angle in the lower left, just like on that board, just so there's no confusion. You ultimately could put it wherever you want. It's just easy to visualize that swing side, as you saw today. Perhaps. Okay, I need some help though with this one. So I'm looking for help from the one and only Nola. We need to solve the triangle, so what do we do first? And 12 over a sine of 31, you said? 20.5. 31 over sine of B. This is great. I'm gonna stop it for just a second. I would personally write sine of B over 31 equals sine of 20.5 over 12, even though ultimately it's the same thing. But for me, I really like the variables to be 1 on the left and 2 up top. So you could do whatever you like, but I think the next step was just to cross multiply. Nice.
Hi.
Ooh. Okay, yeah, exactly. And is that for the first triangle or the second triangle? Okay, so 64.783. Are we good with that? Nice.
Add that 25. 94.
Okay, that seems right to me.
And then. Solve this thing by doing the lots.
Nice. And you already did that? Okay. So you had a direction.
And then,
Okay, perfect. Hey, Rohan?
and then C, what did I go, I got 34.149.
34.149. Did anyone else get these values? Okay, nice. Thank you for the tag team back there. Let's just make sure the biggest angle is the opposite from the longest side. Smallest angle, shortest side, is all lined up, okay? Please make sure to see that, because that's one great way to find a possible error. Does anyone still have this value in their calculator? What is 31 times sine of 20.5 over 12? 0.9. 0.905. 5-ish. Okay. Okay. Noah, did you want to finish this, or should I move on to someone else? So kind. Okay, because we're only halfway done. And really, one of the big parts about this problem is knowing that you're halfway done. If you just move on and say, I'm done with the problem. After doing only what Nolan's done, then that's one concern that I have, that you haven't analyzed appropriately. So Nola recognizes that there's more to be done, and her very generous nature has said, it's okay to move on. Thank you. And thank you for your help. Hudson, what can we do?
I really haven't done much.
Okay, well, let's work on it. Okay, because we know that this one here, angle B is, angle B is 64.783. 64.783, and we're looking for this one over here. I think if everyone does like 30 seconds to check with their neighbor to see what this. There.
This one, you know that,
6 seconds left.
these are complementary, I mean, these are supplementary.
Okay.
Oh. And this one.
Okay.
So-
Well, Hudson, do you have enough time to figure out what's going on here? Okay, these are anything supplementary at the time? Okay, so we have that. 115.2? Okay. 115.2. Well, for degrees, I did say nearest tenth, but since we're gonna be building on this, I think using law of. Unless otherwise noted, angle to be rounded to the nearest tenth, side to be rounded to the nearest thousandth, 3 decimal places, and that's just to kind of get you in the frame of reference that calculus would expect you.
Is there a bigger reason why it's usual?
Well, degrees are already out of 360, so a fraction of a single degree is already pretty exact. But yeah, calculus just, it wants super exact when it comes to integers or lengths and such. Okay, so we have 115, approximately 115.2. Now, Hudson, I don't know if you've already finished the problem, but could you tell us the direction you would head from here?
Yeah. What you wanna find the angle.
Okay, 44.8, thank you. And then to get the little c, is that wrong? Point, 0.3. Okay, 0.3. And then to get small c, Hudson, have you already figured out?
And then you have to set up,
Nice, okay, yeah. So if we do this, and that's our measure. So if you do that, then c is equal to approximately. Oh, I'm hearing 30s and 20s. 23 point something, is that right?
I got 23.
23.931, is that right?
Yeah.
Yes, there. Okay,
If you want to solve for angle B in the second time, how is it?
good question. Thank you. And that's one of the reasons I want to go here with this sign of B equals 0.905. Let's go back to unit circle and take a look at the answers to this. Sine of B is equal to 0.905. Let's take a look at our unit circle here. Do you see which angles have a sign that's equal to 0.905? There's one, but here's on the y-axis, like go to 0.9-ish. So I have one angle over here, the other angle here. Our calculator tells us that what is it, 64.8 on this side. The other angle it's supplement at the 180 minus 64.8. So our calculator won't tell us it directly using inverse sine, but we could analyze with unit circle to get that other angle that one.
So she's 180 minus whatever value.
Yes, exactly. Okay.
So to find enough, to find the angle of the other triangle. To find the.
Wait, so after we have this, if I can,
No, because we know when from the first triangle, we solved it all.
yes.
We wouldn't need the outside.
Oh, correct. Well, you kind of do indirectly. You need log signs to get this, but it's intuition, and then analysis. But yeah, intuition too. It kind of like one. Any questions? Who understands from start to finish this problem that we did here? Okay, before you do the next one, I definitely want you to talk about if anything is unclear. Do you think there might be a problem like this on a quiz or a test? 100%. Yeah, you could count on it. So come correct. Be ready. You have example 13. Again, work out any bugs from the last one before you do. I'm gonna switch this a little bit. I'm gonna make this a 23 here. I don't like that 22
Well, for the A side,
for A.
That's.
Little.
find the one.
Just for A.
Yeah.
You can do both.
Oh, but we're getting so much more. There's only one.
So I would just, I would do it with that one.
The triangle with this.
No, but, you have to do it, but you have wait, then it's gonna be.
Wait, you didn't, you made it not one triangle.
So now it's two, right? Now we're finding two triangles.
You said find it.
Let's say the one, but maybe it's made a mistake. Okay, that's slow.
Yeah, then you can't do it.
Maybe that, yeah. Okay, I just gotta go for it.
We were one triangle, you do it all, so. No, then,
No.
no, if they're both 22, you can just do side, roll over, middle, you know.
Yeah, you're right, huh? You're right.
Yeah, now we're fine.
Angle nearest 10.
I'm gonna be more than that.
You did one.
No, they're using no. It's because that last, thing that's the inside of the larger than that. Oh, you're right.
Because 23. Only took 4 to 50 years. How is it not? Anything else can if I talk to you.
And long enough to make a triangle.
More than the right.
Oh, it's still 1 thing. No, it's 23. If it swing. Oh, so you're right. Oh, yeah, you're right. It's not. Think if I did swing, it goes under. That's why he said. I understand that. I can see what I'm doing.
Stop touching you. Okay.
A little awkward right now.
But then you are member.
Yeah.
It's called back to you know.
No, that's so dumb.
You about finished? 10 seconds. Okay, we ready? Ready or not? Joanna, could you help us with this one, please? Okay, let's get the Joanna a chance to talk. Could you give us the equation before arc sine, please? Like, what did you start with for B? Okay, and for B, I think, I guess from there, let's just skip to the end. What did you get for B? 39.8. Do we agree with that? 39.8?
Yep.
Okay, you proceed to continue, or? Say that again? 98.2? Okay, and from there, did you get C? Nice, I'm having a hard time doing that in my head. Could you tell me the final result? 34.022. Are we good with that? Any questions? Okay, now I'm gonna proceed from here and say you blindly went and you made a second triangle. You tried to make a swing side and you did something like this. You got 42 degrees here. You got this one was 39.8 degrees. So that would mean that this is what, 140.2 degrees? Is that right? Is that what it can be forced into? If you really tried to force it, this is 23 right here. Okay, so if I'm solving this ABC, maybe there is another triangle. I kind of want to see what's going on here. I know this is 42 degrees. B is approximately 140.2. Is that 140.2? You see where I got that from?
Yeah.
It is the supplement of the other B. So if this is true, then C would be equal to -2-ish, negative 1.8, which is a problem. So if you run into an issue, please make sure that you stop. I think what I did is I just proved that there is no second triangle by, what is that called? Proof by contradiction. Right, assume that there is another triangle. That's called indirect proof. Remember, assume temporarily that like the yeah. Exactly. Work backwards. So you come to a contradiction. So that's what we just did. We just proved that this is just, it doesn't exist. But we should have known that already. We kind of wasted time because already we knew there was no second triangle because the swing side is longer than the fixed side. We just wasted a bunch of time. Now I came to number 14. I meant like on a test or something like that. But we could do number 14 here. Or can we? Don't. No.
We gotta prove the right side, the triangle.
We finished? Top 14? Have you shown that it's not a triangle? Okay. Miles, can you help us out with this one, please?
Okay, yeah, so what I did was, I drew it almost triangle,
Okay,
so like,
we could draw a triangle,
not, yeah.
85 degrees. So this is like 15 and this is 25.
Yeah,
Okay.
and then, I did sine B over 25, and did sine 35.
You okay?
And then we did sine B, we did 25, sine 35, so we
Okay, can you tell me if you type all that into your calculator, 25 times sine of 85 divided by
You
15,
get 1.66.
1.66.
And then you can't take the arc sine because arc sine must be between. Yeah, negative and negative, and then because it's over negative.
Speaks the truth. Make sense? Once you see that number that's greater than 1, just stop. Don't waste your time with the inverse sine or the arc sine. Sophia?
So I think I think the art sign that that's what everything. But you have to find this
I see. So you did this. So you did this, right? That's fine. And then the calculator came up with error, I imagine. Okay, yeah, it just said, it calculated the inside, but then enough. Oh, it's bigger than 1, not allowed. So whatever you like, this is fine.
But all these tests, we can just write it like that. Just write it.
Yeah, you can say that, and there could be an error there for, a triangle or something like that. But I think this is just really nice, once you see this, it's beginning to. So it's really up to you.
When you just say that because A is on the largest angle and triangle, like, because B is greater than side, it should be the largest. Like, because
Well, no, and this could be like, I think if this were 21, it might work. Just the fact that it's shorter doesn't mean it's not a triangle. It just, this length right here is just, it's struggling to make it to the other side, but it will make it eventually. And it'll be shorter than the 25. But if it's longer than 25, then there is one triangle that's formed. That's when we have to be careful. But shorter than the fixed side, it could be 0, 1, or 2 triangles.
not sure in the fixed side.
Oh.
Doesn't the largest angle produce the largest side?
Oh.
By definition, it is. You do one, you might have got it. Then, and difference is good.
Yeah, it's, you're right. It's, I see what you're saying. I'm sorry to have talked so much in the opposite direction. It's looking bad, isn't it?
We actually don't know.
We don't know the other.
You don't know the other.
You never know,
The other one, I feel like one, yeah.
Everyone is great.
And 5, and then 5.
Yeah.
Yeah.
Logic failed.
Logic failed. You're telling me that.
What is the
one
guy
unit
to do?
angle is gonna make it 25.
Yeah.
25 unit side.
Yeah, Andrea, I say definitely sus if you're looking at this right now, really think about it. And if you draw it like, try to be somewhat accurate about it. I hope that you can see that if this 85, that's pretty close to 90. That 21 has no chance of making it down to the other side. So sometimes intention of some sort of accuracy is helpful. But yeah, really. I like to see that. Yeah, that's the problem. Or either you typed it wrong, or there's actual issue with the lights. Any questions? I'm gonna give you just 2 minutes of silent digestion before I proceed with the last thing of the day. If you take a shift.
And then
The second one. The second problem.
I've seen that. No, I'm going to say that I've seen that.
Yeah, yeah.
Yeah, I think it's, I don't know how it's wrong. I think, well, I want to see, yeah, but I want to know like why, but you see, it's I'm trying to keep everything.
About 20 more seconds.
Okay. We need to talk about it word. Talk about a word and it's not, SSA. The word is bearing. Another word is bearing. Navigation. Oh, navigation. The other word is bearing. Navigation. It's like the people around you reading bearing.
I know. Have you buried? Oh, yeah. It's up. Yeah. Yeah, that'd be like.
Okay,
So
so a bearing just means a direction with respect to north, south, east, or west. Yeah. Now you don't only have 4 choices when you're traveling. You can travel in any direction. So I'm gonna ask you to go back a little bit to page 10. No, page 9, I believe. Yeah, page 9. And I'm not gonna be doing example 10, so you could do it on your own if you like. I'm gonna reserve the right side of this line for a little bit of note taking. So let's talk about directions here. You know that this is north, this is south, this is west, and this one is east.
Never eat sidewalk. Never eat sidewalk.
Does that help?
Yeah.
No, I remember.
Yeah, then you go to the parkway. So never eat
Uh, I just never eat sidewalk foods. Okay, so if you're headed this direction, oh, let me do it nicer. Oh, that's interesting. I can move it. That's kind of cool. So if this is 20 degrees right here, that bearing would be referred to as
Oh, that makes sense.
Okay.
Oh,
Right, that specific bearing would be referred to as this. This is red in 2 different ways. 20 degrees east of north. That's what I was referred to it. Or north, comma, 20 degrees. And it's always given in terms of north and south. You could try to say east 70 degrees north or something like that, but that's just not standard. It's like north and south.
So if we're going in this direction, let's say this is 55 degrees right here. Would you please discuss with your neighbor what would the bearing of that direction be?
South,
So we're gonna start with south and then 55 degrees west, so south, 55 degrees west, or
55 degrees west of.
that's what I prefer, honestly, except it's awkward to start here, 55 degrees west and south.
But either way, it's appropriate.
Okay, now that we have that, I hope it makes sense. Let us discuss a problem about Sophia. Apparently for Gavin Kanan, is this true? Oh, is Canon, is that someone at the school?
Yeah.
Oh, okay. Oh, really?
Yeah.
Nice. Yeah. Dr. Helson wrote this, I'm sure they're both in this class. I'm sure something happened with the purple pencil. Okay, they went on a sailboat ride together. They're traveling due east parallel to the shoreline at 10 miles per hour. At a particular instant of time, the bearing to a lighthouse on the shoreline is 70 degrees east of south, and after continuing for 15 minutes, the bearing becomes 63 degrees east of south. By the distance from the sailboat to the lighthouse currently. And that means second sighting. Second sighting. So I'm gonna help you out with this a little bit. So they're traveling along due east. When they come across. Probably not, a lighthouse, and the lighthouse, of course, is on the shore. Do you see where the lighthouse would be though? If you want to make it accurate, it's saying that it's 70 degrees east of south. So I think, okay, this way is south, which means that maybe here-ish. Does that look like it could be about right? So 70 degrees east of south. I guess first we look south and then 70 degrees to the east.
Oh.
But the story doesn't, in fact, this is where the story begins at the first sighting of the lighthouse. They travel a little bit more, still continuing east. And then they look again to see where the lighthouse is. The house hasn't actually moved, but the bearing from them has, oh, that's nice, it's straight. So would you please fill in this triangle? As much as you can. And answer the question.
Oh, no. Is that new angle? Is that new angle that you want to say you buried? With the parallel.
So this is A, B, and C. So the B is the second sighting. That's one has something to do with 63 degrees, yes. Yeah.
You can assume that like a 90-degree angle and then the south line. And that's how it is. Doesn't work.
Hey,
This is like 7 years. I don't think
Oh, maybe. South.
we'll be calling someone in just a minute or so.
Yeah, it's the 63.
No, it's A. No, they.
No, look, they know what you say.
Oh, really?
Maybe it's 27, so it has to be inside.
Yeah, I think it's.
Did I draw this right?
So I think it's falling. I think the angle is really.
This one.
That one's really new.
Good point.
What is it? Is that wrong? That's actually not.
I don't know. You can't assume by the picture. You can't make assumptions from the drawing. Okay, I need some help here. I need some help. I need fate to help me. Kieran, can you help me with this? Did you get anything about this triangle?
Yeah, so the angle A is,
I'm gonna erase this, so yeah. Are we good with that 20 degrees? And you got 20 because, thank you, okay, it's complimentary. So you got the 20, that's about it. You didn't get, I'm hearing other people arguing that this one is not 63 degrees.
is it or is it not?
It is one of those. It is either is or isn't.
It is not.
Well, let's think about where that came from.
It must be.
It says it's 63 degrees
No, 63.
east of south. So I'm gonna draw another reference here because the south is definitely this way, isn't it? So do you see where the 63 degrees is? Karen, do you see it? You don't see the 63 degrees? Yeah. Isn't that what it means? That's a bearing, 63 degrees. Is that what it is?
Yeah.
Are we good with that?
So if we want 50 degrees.
One, that was some quick mental math. So, you said 153? Maybe 7, a tiny little angle.
It's like 10 miles an hour, they go 15 minutes, so that.
Okay. So you're telling me that the length of AB is 10/4? Are we good with that? 10/4, I'm having a hard time figuring out a distance from 10/4. Could you?
10 for.
I feel like you're making me do math, no distance. 2.5 miles.
Oh,
That I like, 2.5 miles. Are we good with that?
yeah.
I think you use distance equals rate times time. The rate is 10 miles an hour, the time is 15 minutes, but which is just a quarter hours. Which works out to be 10/4 miles, which no one would say 10/4 miles, we simplify that to 5/2 miles. Thank you, exactly. I have to know, when I say 5/2 miles, Miles, do you hear your name when I say that? All right, is it gone? Like, okay. I had a student named Ruthie in my geometry class several years ago, and anytime I said root 3, she's like, Ruthie, 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 like Ruthie. Anytime I said like 5√3, she looked around and said, someone called me? Anyway, I just saw that to you for no particular reason. Okay. So how long will it take them to sit? Oh, so what's the distance from where they are currently to the lighthouse? Did you already get it? I know you can. Can we stop here? But I want to call on one more person. Go ahead and finish it. Yeah, if they go to the lighthouse. They're at B.
Yeah.
Okay, Nathan, can you help us out with this, please?
Yeah,
I'll do that one.
we're finding like the rest of A.
But I'm just going to find the distance from the sailboat to the lighthouse currently, which means we're looking for this right here. I'll call it X, or do you call it something else?
I'll call it M.
Okay, let's call it A then.
So I'm using, so using a lot of time, I
Mhm.
did 2.5 over sine 7 equals A over sine 20 degrees.
Okay, did you get a value there?
So it would be 2.5 times sine 20
Hmm.
divided by sine.
Okay, so I have to change. This is not an approximation, this is exact.
7.0.
And the units would be? Are you asking your neighbor?
Oh.
I'm just kidding. Okay, are we good with this? I hope you've enjoyed the SSA and the law of signs. You have a little bit of time to work on your assignment, so at least take it out and plan your attack.
Got